Okay, so now we have to start from this topic, distinguishing one string from another. Which means that if we have a string, that how can we differentiate or distinguish that that string is different from another one. So this is some theoretical stuff before this example. So let's go through this theoretical stuff first. Suppose alpha be a language or L be a language in sigma star and X any string in sigma star. Then the set L over X, by the way, this is L basically. So you don't have to worry about it. So this is L. So then the set L over X is defined as follows. L over X, this is mathematical representation of this theoretical stuff. So L over X, this then is a set that is equal to Z, which is another string from this sigma star, the same sigma star. So you have to take another string Z from that sigma star such that you have to concatenate that X. This is a string that you already have taken, and then you have to concatenate that X with this Z. This is the X and this is the Z. And after concatenation, if you have some resultant string that will again belongs to that language L, then we can say that this function is now, this language over X set is now set, and then we can say that this is that the new string that you have taken Z, and after concatenation you have the resultant string that is again belongs to that language, then we can say that this resultant string is belonging to that language. So this is the definition or theoretical statement of this mathematical understanding. So after getting this concept, now we can say that if we have two strings X and Y, and these two strings are said to be distinguishable or differentiable with respect to that language L, if L over X, if we draw a something for L over X like this one, and if we draw a L over Y similar to like this one, which means X and Z concatenation and then Y and Z concatenation. If L over X and L over Y are not equal, only then you can say that these two strings X and Y are distinguishable. Or only then you can say that these two strings X and Y are different. Because concatenation of, if concatenation of XZ, X and Z belongs to that language L, and if concatenation of Y and Z belongs to that language L, which means this is belonging to language L, which means that I can write X, Z, and Y, Z. If both are belonging to that language L, then it means that X and Y are not different, they are not distinguishable. I don't have to use the word different, because in this way you can say that might be it is the same string. No, I have to use the word distinguishable, which means that xz, if xz and yz, two different concatenations belonging to language L, then we can say that these two strings x and y are not distinguishable. But if xz and yz are not equal, if one is belonging to that language L and other is not belonging to that language L, then we can say this situation, L over x not equal to L over y. And only in this way we can infer a result that x and y are distinguishable. Any string z that is in one of two sets. What are those sets? This one set, and this is another set. Any string z that is in one of two sets, but not the other. For example, xz for this one belongs to L, but yz not belongs to L, or vice versa. Vice versa means yz belongs to L and xz not belongs to L. If from these two strings xz and yz, if I want to finish this annotation and I want to clear all my drawings. Now the page will move. Yes. So any string z that is in one of two sets, which means xz, this one and that one, is said to be distinguish x and y with respect to L. So this is theoretical step. If xz is belonging to L and xz is not belonging to L, then you can say x and y are distinguishable with respect to that language L. And if L over x and L over y, here it is not equal, but here if L over x and L over y are equal, then you can say x and y, which are the two strings that you have taken here, are indistinguishable with respect to L, or you can say x and y are not distinguishable with respect to L. So this is very much easy definition in understanding. So now we will prove this theoretical stuff with a practical example. For example, there is a language L of all strings in 0 and comma 1, which means all possible combination of 0 and 1 that end in 1 0. End in 1 0. So now you can understand that the strings that you will get from this language L will end at 1 0. Now we can say strings 0 0, which is we are supposing x, and another string 0 1, which we are supposing y. Strings 0 0 and 0 1 are distinguishable with respect to this language L, because if z is 0, if we will take third string z as 0, then after concatenation we will have 0 0 and this 0 triple 0. This is x part, this is z part. So triple 0. So triple 0 will come from here, but it is not ending with 1 0. So that's why it is not belonging to that language. And 0 1 and this 0 0 1 and this 0, this is y part, this is z part. So this 0 comes from this part. This is 1 0, which is here as a string. So this string, you can say this string belongs to this language. So You can say this one L over X not equal to L over Y, like this. L over X not equal to L over Y. And this example is simply saying that this 00 and 01, which are the two strings, are distinguishable with respect to that language L. Only these particular strings 00 and 01. We can now take another example, which gives us xz not belongs to L. This is the further xz not belongs to L, yz belongs to L. You can write this thing in mathematical form, and these are not equal. So L over X L not equal to L over Y. So this is just an explanation of for this theoretical stuff. Similarly, if we take another two strings, 0 and 00, this is now X and this is now Y. And then L over X and L over Y are equal and indistinguishable. Now, in this case, the property of ending is 10 depends on Z string. So, if these are two strings, 0 and 00, which are X and Y, and if we don't know the Z, and if we have to prove that L over X and L over Y are indistinguishable, if we consider the previous Z, which is 0, then it is 00, which means that it is not belonging to L. And if we concatenate here 000 which is again not belonging to Y, just a moment, I am just revising my definitions. In definition, xz must belongs to L. Okay, if we have two strings 0 and 00, like X and Y here on the screen, and if Z is again 0, then it would be then xz become 00 and yz becomes 000. This 00 is again not belongs to this language, which is the strings ending in 10, and this 000 is again a string not belonging to this language, which is ending in 10. So both languages show the set L over X and L over Y are the sets in which the resultant strings xz and yz are not belonging to this language L, which means now we cannot write L over X not equal to L over Y because the strings are not belonging to the language L. So what we can write? We can write that L over X and L over Y are equal. So you don't have to think particularly equal means similar strings are like that. You have to think that either we can extract some difference in their property. For example, xz is a string
which is not belonging to the language L. This is its property, not belonging. And here, 000 is a string which is not belonging to the language L, which is again a property of not belonging. So, when there is a property of not belonging to the language L, this language with string X has the property not belonging. This set with the resultant string YZ not belonging to that language has the property of not belonging. So this their property is basically equal. So that's why it is written as L over X and L over Y are equal. And when their properties are equal, then you can say that they are indistinguishable. Now you cannot draw some conclusion. So that's why it is written as indistinguishable. And now, so, and for example, why they are not equal? Because 00 and 000 is not a string from the language L, this language, which is ending in 10. So ending in 10 totally depends on the Z string. If we will take Z some other string, um, um, for example, we have to take some other strings X and Y, and then we have to take some other Z string, and then we can check either their L over X and L over Y are unequal or equal. And when they are unequal and one part is belonging to that language, only then you can say that the two strings are distinguishable. उर्दू में कहूँगा कि कोई भी अगर कोई फॉर एग्जांपल ये लैंग्वेज एल है, ये आपको दी गई है, आप कोई दो स्ट्रिंग्स लेंगे एक्स और वाई, जेड के साथ कंकैटिनेट करेंगे और फिर चेक करेंगे कि जो रिजल्टेंट स्ट्रिंग है वो लैंग्वेज को बिलोंग कर रही है या नहीं. जब एक रिजल्टेंट स्ट्रिंग लैंग्वेज को बिलोंग कर रही हो और दूसरी ना कर रही हो, तो फिर इसका मतलब है, जैसे कि ये डेफिनेशन में कहा था कि एनी स्ट्रिंग जेड दैट इज इन वन ऑफ टू सेट्स, दो सेट में से किसी एक में होगी. तो यहाँ पे ये एक तो है, दूसरी नहीं है. तो जब इस तरह की कंडीशन होगी तो फिर आप कह सकेंगे कि जो स्ट्रिंग्स हैं एक्स और वाई वो डिस्टिंग्विशेबल है, उनके अंदर फ़र्क किया जा सकता है. और जब वो आ जाए इक्वल वाले स्टेटस में, उनमें फ़र्क ना किया जा सके, तो फिर हम उसको इनडिस्टिंग्विशेबल कह देंगे. ओके, नाउ मूव ऑन टू दिस लेमा. What this lemma is saying, suppose there is a language L which is a subset of sigma star, and now you will understand what it means. And there is a FA according to our previous definition containing 5 tuples, and that FA is accepting or recognizing this language L. So suppose this thing, keep this thing in your mind that there is an FA, and this FA is accepting this language which we are supposing. Now, if X and Y are two strings in sigma star, if you will take some two strings X and Y from sigma star, which is a all possible combination of the given input symbols, if X and Y are two strings in sigma star that are distinguishable, you have to keep this definition in your mind like this one as you have taken. If those are distinguishable with respect to L, then in mathematical form we can write something like this: delta star, and you have to start with initial state q0, and then you have to take this uh, uh, string x, and then similarly delta star q0 initial string and then y, and their extended transition functions would not be equal. Their transition must be different on FA because they are distinguishable, which means they are, I don't have to say different, but for understanding, I can use this word different because X and Y are different. One is belonging to the language and another one is not belonging to the language. So that's why their transitions would not be equal. So this is clear. This is clear, and this is quite easy to understand that if there are two different strings, if there are two distinguishable strings, then their transition must also be different. So that's why it is written here. Now, this is the last slide, and here we have an FA for a language LN, and there is a condition on this LN. Suppose, and what is that condition? That n is greater than or equal to 1. So the value of n can be 1 or greater than 1. 1, 2, 3, 4, 5. And now another uh, definition or the language for this FA. Ln is equal to x is a string which is belong to 0 1 star, which is a sigma star, and these are the two symbols, such that the length of the string x greater than or equal to n. So which means that the length of string x would be greater than or equal to 1 1, which is, for example, here it is mentioned here, and the nth symbol from the right, nth, if so, and the nth symbol from the right in x is 1. So here something is missing, which is the value for the n. So we have to give some fixed value. If the value of n is not given here in this definition of the language, then we cannot uh, draw a FA for that language, because then we have to consider n is equal to 1 and then 2 and then 3 and so on. So that's why we don't have a fixed value of n here. But if we want to draw an FA, uh, then we have to fix the value of n here for this language ln. So this FA is drawn here for a fixed length, maybe 1, 2, 3, 3. So here n is, you can say, 3. For here, for this FA, the value of n is 3. So you can now reconsider this definition of the language. Ln is equal to x belongs to x is a string, such that the length of the string greater than or equal to 3, 3, and the third symbol from the right in any string is 1. So from the right. So first thing, that the length of the string should be greater than or equal to 3. The length of the string can be 3, 4, 5, 6, and so on. And other thing is, you have to traverse from the right direction of the string towards left, and then you have to see, or then you have to check that the third symbol from the right in that string should be or must be 1. So now keep these things in your mind, then you have to draw the FA. So now maybe I have to uh, reduce the size of the page. Now this is my starting state. So take the octal system, 000, 001. So if you want to draw, I don't know either this is something, I can try this on my small board, but I am not sure that it would be feasible or not. Uh, so first I have to stop the sharing, and now when I will stop, then you can see, uh, now you can see this board maybe in this direction. So I am starting, so you have to think first.
for for the language. What is the language? I have the strings. My value of n is now 3, and I have the strings with the length greater than or equal to 3, and the third symbol from the right towards the left is 1. So first thing that, for example, 000, this is the minimum string. So now the length is 3, and the third symbol from the right, 1, 2, 3, is not 1. So this is not a legal string for this language. Okay. Then maybe 001. No, it is not. So my minimum length for the string is 3. I can keep the greater length strings, but I am just considering with the minimal condition. Similarly, 010. So this is an octal system. No, from here, the third symbol is not 1, third symbol is not 1. So these are illegal strings. And then maybe 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So now you can see that these are the illegal strings, but these are the legal strings because 1, 2, 3, and it is a 1 here, 1 here, 1 here, 1 here. So now you have some idea about the design of the FA that we want to draw. These are the minimum strings, all possible combination of strings with minimum length 3. We can consider 4, 5, 6, but this is something afterwards. So these are the strings you have to keep in your mind. And now draw that FA. Okay, this is my starting state, and 000. I can draw first 1, 0, then maybe 2, 0, and then maybe 3, 0. So in this way, 0, 0, 0, and I am reaching here at, you can write it as 000. Similarly, 0, 0, and then 1. So 0, 0, 1, and then maybe from here 0, and then you can think in this way, and then maybe this is 0, 1, and then I have to 0, and then 1, and this is 1, 0, 1, 0, and this is 0, 1, 0, and then maybe 1 here, 1. So 0, 1, 1, this is 3. So I am covering these strings first, and I am not making these states as the final states. So now, okay, these are something rejected states, you can say, are states in which the illegal strings will remain in between the states and they will not reach at the final states. And now I have to think, this is the zero possibility. All two degree. Two is the output degree. Output degree complete. Output degree complete because there are two symbols. Two symbols complete. So one, maybe the other one is. So I have to think in this way. So it is one, and now I have to think in this way. Maybe 1, 0, and then maybe it is 1, 0, and it is 0. So 1, 0, 0. So this is something, this one, 4, and it is a valid string. So I will make this state an acceptance state. Similarly, 1 0, so now I have to make the 5. So here 1 and 1 0 1, so I have to double circle it because the third symbol is 1. So you have to draw the arrows. Similarly, 0, another possibility is 1, and then you can, I am just drawing it speedily. 1, this is 5, and then 0 1 1 1 0, and then 1 1 1 triple 1, and I have to draw the arrows, and these are my final states. But this is not finished yet. Outer degree complete argument, but here the degrees are not complete. Now you have, now my strings can be 000 or maybe some other zeros here in this way. So 5 zeros maybe. If it is 5 0, then what you can do, 0 0 0 and 000. Can I make a loop here? Check it. If I 0, if I make a loop here 0, then these 5 zeros are finished here. And if I will make 000 and 0 here, like this one, then it is 0 0 1 0 0 and 1 2 3. This is illegal string, but this is now legal string. 0 0 1 0 0. The third symbol 1 2 3. This is 1. So now I have to think over it. Triple 0 0 1 double 0 0 0. This is 1. 0 0 1 and then double 0. So double 0. So this state is accepting zeros. So I can make a edge here with 0. Okay. Okay. And then this state is accepting 0. Maybe it is false, but first I have to check it. Or then I can, this is 0 1 0, and okay, I can make it here with arrow here, and it is 0. Now 0 0 1 0 and 0, and the third symbol is 1, and I am making it possible to reach at the acceptance state. Is there an error in it? You have to consider it. But at the moment there is no error. 0 0 1, it's okay because there is no any other edge going towards another state. Now 0 1 0 and then 0. For example, take this one 0 1 0 0. 0 1 0, and this edge which I have already made, this is making my this string possible to reach at the acceptance stage, which is a legal string. But if you introduce another 0, then this is not a legal string, it is illegal string. It should be in some other state, not the accepting state. So 0 1 0 0. So 0 1 0 0, and if we have again 0 here, so we have to uh, maybe I don't know, but if I will make it here, No, this is an error because if I will take another zero, then it will reach here. So maybe I will have to move it here with zero. I don't know, but I will check it with my proceedings. I will check it as I will move forward. So, okay, zero, one, triple zero. So, zero, one, triple zero, 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 zero. I'm reaching somewhere else. Okay, but zero, one, double zero. Now the third string is one, so this is a valid string. Zero, double one, zero, zero. Zero, one, one, and then okay, I can. This is not acceptance state. Zero, one, one. If I will make it zero and then zero, now it is accepting because it is a legal string. So zero, one, one, zero, and then zero. Now it is. Now this string is accepting because it is a legal string. At the moment, we are going in a right direction. So now here, if we make this thing, so 1 and 0 four times, 1 and 0 four times, 1, 0, 2, 0, 3, 0, 4, 0. So this is illegal string. That's okay, perfect. Now double zero, 1, 0, 1. Now this is a legal string, 1, 0, 1, and then double zero, 1, 0, 1, and then double zero. Okay, double zero. So 0, yes. So 0 and then here. So this is now my 0, and then after taking 0 I am again reaching at acceptance state. So this is now my string 1 0 100. So 1 0 1 0 and then 0 I am reaching here. And now again 0 0. So now this is illegal string. Double one triple zero. Double one 0 and then triple zero. So this is illegal string. So illegal string, so we have to maybe move this string here. It is better always because this is legal string. So I don't have a space here, so that's why I draw this line here. Okay, and now triple one double zero. This is now legal string because the third symbol is one. Triple one double zero. Okay, check it. One 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 triple one and then double zero. Okay, this is my state. Double zero zero. I can move it here and then here. Zero zero. But this is something. Sometime it. This is a new creation, so it will create some problems. So I have already a space for these things, which is this one. So triple one double zero. So this is one 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 triple one, and I have to move it here. Zero. Triple one. This is zero, and then after taking this zero, I am reaching at this acceptance state. So now this is accepted. So these strings are, at the moment, these strings are accepting and rejecting properly. But for example, one edge is remaining here, it is incomplete. One is finished, other edges remaining here. This state is again without, there is one edge here, but other one is remaining. This state, one edge is here, other one is remaining. This state, one edge is going outward, but other one is remaining. Similarly, this one, outer degree only one, second one is remaining. Outer degree only one, second one is remaining. Here, one edge is one outer degree, other one is remaining. So you have to think in this way. You have to produce strings like this one. You can take another string, for example, despite of this one. You can take okay 1 1, and then you have to think like this one, 0 0 0 1 1 0 0 0 1 1. Okay, this is illegal string, must be rejected. So 1 1. So here I don't know. So maybe this is state is accepting one, so I can keep one here, and then uh, one, and this one maybe. Yes, it is better. You can put something here. So it will be complicated, but you have to finish your drawing in this way. You have to finish your drawing in this way. And now coming back to uh, notes, coming back to notes, I can show you. Um, I can show you now on these notes that this is one edge and other one is, so this state is complete. Okay, this edge, this is one edge and this other edge is, so this state is also complete. This is one edge, but other edge is missing here. Okay, this is one edge, other one is missing here. This is one edge, other edge is missing here. This is one edge, other one is missing here. This is one edge, other one is missing, uh, and two edges are complete here. So these states from 0 1 0 to 1 1 0, these states have incomplete edges. So now your job is to, by the way, this FA is perfect, but its some of its edges are incomplete. You have to complete this FA by yourself. And now we have a theorem statement here, um, which is the language Paul for palindromes over the alphabet 0 1. Um, so if I say that draw a FA for a palindrome, what is palindrome? A string, if you move from left to right or from right to left. If you read alphabets of a string from left to right or from right to left, uh, it will be same. It will be same alphabet. For example, ABA. So if you read it, this string, if you read the string ABA from left to right, it is ABA. If you read it from right to left, it is again ABA. So it is a palindrome. So if I say to you to draw an FA for a palindrome, then it is not possible. The language Paul of palindrome over the alphabet 0 1 cannot be accepted by any FA and is therefore not regular. So the language of palindrome is not regular language. Uh, so we cannot draw an FA for a palindrome. Uh, uh, because some FA will not be able to accept this language. So therefore now we have to shift the category from regular languages to some other languages, and we will see this thing in the next lecture, inshallah. uh, Up to that point, up to that time, uh, take care of yourself See you.